Okay, we're going to start up here on fire alarm symbols. Let's zoom in on EO.02. Okay, these fire alarm symbols are 20 years old from this set of Oshpod plans, so they're going to be slightly different when you're looking at another set of fire alarm drawings. So I would recommend that you get a newer set of drawings off one of your job sites and take a look at those. I'll see if I can present something at the end of this one here that shows some of the newer fire alarm symbols. Okay, to start out, let's start at the beginning. The first symbol you can see here is a fire alarm visual station, strobe only. It's for 15 candela. Now 15 is the minimum candelas for the brightness of the strobe lights, and typically, we normally see as high as 110 candelas in some of the larger open rooms. And on the right side of the chart, it shows you an 82-inch above floor finish to the center line of the visual device. The next item is just an F and a square for a fire alarm manual pull station. Typically you'll find these at your exits or by stairways in multi-story buildings. Next item is a fire alarm horn. You notice it kind of looks like a little horn blowing out. There's also a chime symbol that you'll see that isn't really on this particular set of drawings here. We don't use horns in hospitals, except maybe in very large basements or mechanical rooms where there's a lot of noise, because we need to have chime sounding devices within anywhere that the public or the patients are being seen. So typically we're going to see fire alarm chimes, not fire alarm horns, and that's at 7'4" to above floor finish to the center line of the device. Then we've got a magnetic door holder, which we'll find typically on our dual egress or cross corridor doors that are held open so that as we go through smoke compartments, we don't have doors that we got to open and close all the time. We'll put a magnetic door holder device on the wall and then open the door so that the magnet holds the door open. The moment the fire alarm goes off, it basically drops that connection. Magnet goes away and the door just goes ahead and shuts and latches, which allows our smoke compartment doors to then seal so that the smoke can't freely travel within from smoke compartment to smoke compartment. Then we've got our fire alarm smoke detector, which is just a circle with a D for a detector. They do have one down below here that's an H for a heat detector. So when you're looking for the circle, you got a circle D or circle H. Then you've got a fire alarm annunciator panel, fire alarm control panels, fire alarm relays, fire alarm zone addressable modules. Post indicator valves would be a fire alarm coverage for a riser standpipe, for instance, or at a valve location. It'll alert you when that valve is closed off. Then you got a fire alarm speaker, FS. You'll see that quite a bit in the corridor areas. Then you got a duct smoke detector with a S next to it, which stands for supply duct, and a rectangular D with an R for return, a duct smoke detector. And then we got a FS, fire sprinkler system flow switch, which typically is at your riser locations on a floor-by-floor basis. That if there's any flow in the system, it tells the fire alarm that you've got water flowing, possibly because a head popped and there's a fire somewhere. And also a fire sprinkler system valve status switch, which just tells you whether it's open or closed. All right, now we're going to go ahead and take a look at a floor plan and take a look at where these symbols are placed. Now we're on the second floor floor plan. Let's go ahead and zoom in and take a look at some of our devices. Before we do, actually look up in the top right. We have some electrical notes and also some fire alarm notes to be aware of. So we should glance over those to see if there's any important information in there. And we're going to zoom in here. We'll start on the top left. right, so here we have a, let's call it a corridor, and we're going outside through this corridor, and you can see they've got a dual egress door here. If you look for my little hand on the screen, and you'll see there's an R, a fire alarm relay, and there is a D, a smoke detector, and then FS, that's a fire alarm speaker. Then this D with an R is telling you that we have a duct smoke detector on the return air duct system up above the ceiling here. Let's continue down the corridor. Here we've got a fire alarm, and that would be, one moment, I need to double check that symbol. Okay, this F with the triangle on top is a fire alarm strobe device, which would typically, like we noticed on this per the schedule, is a 15 candela rating. And you can see once again we have a fire alarm relay, door mag hold open, or excuse me, the D with an S is a duct smoke detector, and I don't see the symbol here on this one for the magnetic door hold open, so there is not one here. Okay, FS is fire alarm speaker system. D is duct smoke detector. Jump down here, you can see on the lower right these two half shaded boxes here are showing these egress doors here are held open with a mag hold open device with a speaker and a D, which would be our smoke detector. Over here near the stairway exit, you can see a manual pull station with a visual 15 candela strobe device and a fire alarm speaker. Inside the toilet room, you can see we've got a strobe device. Up inside the dishwashing room, we have a fire alarm speaker and a visual device. Into the kitchen, you can see another visual device, and we have smoke detectors within the space. Typical patient room, we have a single smoke detector, and notice there is no smoke detector in the toilet room. Typical patient rooms all have a single smoke detector in them. Now let's try going to another area of the drawings. Now we are in another area of level 2 on floor area A. Let's take a look at this space here. We've got a visual device, a speaker, another visual device in the toilet room, speaker, smoke detector, visual device that covers this general area. You notice these two are a certain distance apart, so that 15 candela, there's enough of a distance there that the one could not cover the space, so we have two of them. This one covers this area going this way and forward, and this one here can also spread the light around this room here. Okay, then reception area, we have a speaker in the ceiling. We have a smoke detector in the waiting room, a speaker, a pull station, and a visual device, and a combination fire smoke damper on the return air duct, another visual device in the corridor, a duct smoke detector on the return air duct, and another combination fire smoke damper in the return air duct. Going down the corridor, you have your dual egress doors with a fire alarm pull station, visual device, duct smoke detector at the return air duct and the supply air duct. I think we've kind of covered enough when it comes to some of these symbols. Let's move on. Now let's take a look at the nurse call symbols on EO.02. Okay, let's start at the top. EP is for emergency pull cord station, typically found in showers and in patient toilet rooms or in any patient bathroom. Then we have an SP, single patient station with a pillow speaker. That's basically the, you're going to have a device, a pillow speaker with a bunch of buttons on it for calling your nurse, changing your TV, etc. Little all-in-one device there. Then you've got a CB, a code blue station that typically is placed inside all the patient rooms. In case a situation occurs, they can hit code blue and get staff there as quickly as possible. Then you have an S, a staff station, which is typically where the staff will be located, certain spaces. Then you've got a duty station that's similar to that. A dome light is typically a light that will be above a patient room door that when anybody performs hits a code blue button or the emergency pull cord in a patient room, the light over the door will notify any staff that's in the corridor, or they can just look down the corridor and see that light go on and respond immediately to that room. We've got intersection zone lights. We'll get to that another time. NM is a nurse call master station that would be located at the typical nurse call station. We have a code blue annunciator, which would also typically be located at a PBX or at the nurse station. VP, visual station with call cord. Nurse call annunciator, which would typically be at your nurse call or nurse station desk in a patient area. And ES, an emergency staff station to ring at, in this case, the second floor nurses station. So there's some of our symbols. We're probably only going to see 4 to 6 of these typically on the majority of the rooms. Let's jump to one of those rooms now. Okay, shown here in the center of the screen in patient room 2802, you'll see the patient head wall location, which is located at the head of the patient bed. You'll see you have a code blue station here and a single patient station, which would be basically your pillow speaker with all your other nurse call buttons on it. And in your patient toilet room, in the shower, you've got an emergency pull station with a cord that hangs down within 12 inches of the floor in case you should fall. And there'll be another emergency pull cord station for nurse call adjacent to the water closet. Now let's just go over and take just a little bit of a refresher. You'll see that this symbol up here, the triangle half shaded, is a telephone data outlet at the patient head wall. We have a smoke detector in the center of the room, and also looks like a TF, which, one moment please. Okay, the TF is basically for your television, cable TV hookup. Outside the room you see the dome light that when you hit any of the nurse call type buttons, it will go ahead and turn on a dome light here in the corner that'll be solid white, maybe solid blue, or flashing. Each one tells the nurse a different thing. All right, let's see if there's anything else that's worth looking at on this page having to do with nurse call. No, that's pretty standard. Let's move on. Okay, now we're looking at page EO.03. We have on the left side the contractor furnished legend for equipment, and on the right side the owner furnished equipment legend for the first floor. Let's zoom in. Okay, you can take a look here. The first one is a CF-1, that is an air curtain. If you look at the headers along the top, you'll see equipment ID, equipment type, location, in other words, what room, voltage and phase, watts, horsepower, what branch of the system, is it normal or E-power, and on E-power, is it life safety, critical, or equipment branch, the connection type, cord and plug, or hardwired in, to a disconnect or a J-box, what is the wire size that will be used to connect that piece of equipment up, category, and remarks. All right, so let's go ahead and take a look at CF1, an air curtain, which is in corridor 1C40, and take a look at that. Okay, let's take a look here at this air curtain, CF-1. Here's where it's located. It's on panel LEQ 1B1. That's the equipment branch, circuit 26. And we have a motor in there. And it's air curtain CF1. At that CF1 air curtain, there was a circle number 7 next to it that says furnish and install a non-fused disconnect to serve the air curtain CF-1. And the disconnect shall be mounted above accessible ceiling area and in compliance with the NEC. Well, let's call that first off the CEC. And also the what has to happen to make this accessible in the above ceiling space? We need to have equipment space up there in front of the disconnect that has some width to it and some distance in front of the non-fused disconnect switch for service and maintenance. Let's drop down and show you that circle 7. There's our air curtain in the center, CF1, and there's the circle 7 to the non-fused disconnect. Now we're back at the contractor equipment legend, or contractor provided equipment legend on the first floor. Let's take a look on the left side here. You see some med gas alarm panels, shows you the room number, life safety branch, the wiring size. Let's drop down a bit. UH1, unit heater, room 1C42, equipment branch, direct connection, the wire size. It's got a motor. Moving on down, CHWP-1, a chilled water pump. Notice these are all the same room. This is a mechanical room. Equipment branch power, disconnect at the pump, the wire sizes. So you get the drift. Now let's take a look at the owner provided equipment legend. It's right next to it. Typically smaller item stuff, such as, let's take a look at the going down a bit. We've got a MRI cabinet, film processor, copier, fax, coffee maker, television, under-counter refrigerator. These are all small items that are being placed in the facility that will be plugged into the receptacle provided by the electrician. It talks about different the room, voltage and phase, amperage, what branch of the system that the power is coming from, wire sizes, some remarks such as dedicated, meaning that particular circuit is only going to go to the coffee maker. It doesn't share that circuit with, let's say, the toaster or the TV or the fax or the copier. That particular circuit is only for the coffee maker. All right. So we'll zoom down a little bit, show you some other items. You got a time clock here, surgical light, actually, lasers, C-arms, washers, sterilizers, all the wiring sizes, the branch of the power. Is it cordon plugged or is it hard connected, with flex or conduits to a J-box? Now let's take a look at the kitchen equipment legend that's up on the second floor. Okay, on the left side you'll see what the identification for the piece of equipment, the connection, whether it's a cordon plug, single receptacle, J-box, etc. The rating for that particular piece of equipment in amps. Voltage is shown. This particular freezer has a receptacle built into the wall at 86 inches above the finished floor. It's on the equipment branch. Let's drop down to something else. The slicer, duplex receptacle, 9.8 amps, 120 volt. Receptacles at the wall at an elevation of 50 inches above the floor, normal branch. So you get the drift here. Let's just briefly look at some more of these. Shown here is the large-scale electrical plan, page E 6.01. So a lot of the equipment that we saw in that kitchen legend, you'll find here. Let's start on the left side. You'll see the freezer with a receptacle, wall supported, 86 inches above the floor. Refrigerator, 86 inches above the floor for that receptacle again. Same thing with the one down below. It shows you the panel and circuit that will be providing power to those receptacles. And as you can see, they're dedicated. This one refrigerator, circuit 14, the other refrigerator, circuit 12, the other freezer, circuit 10, all on the same equipment branch panel. Now let's jump over toward the middle of the room. You'll see, well, actually, let's drop to the bottom. You'll see here the coffee brewer and iced tea brewer. And down below, it gives you the height of that receptacle off the floor at 50 inches. You have an ice cube maker that's hardwired into the junction box, and that runs over to number 14. Let's take a look at circle 14 on our drawing. And it says furnish and install a 120 volt 20 amp circuit breaker, NEMA 1 enclosure, flush mounted to serve the ice maker. So this is just basically showing you the location. And it's recessed or flush mounted. Okay, I think we've looked at enough here. Now let's take a look at the equipment legend for the roof. Okay, on the left side, let's take a look. We have exhaust fans 1, 2, and 3, RTU-1. This is rooftop unit, also known as an air handler or an AHU, air handling unit. Exhaust fans again, more rooftop units, more exhaust fans, a makeup air unit, SF1, which is a exhaust fan, and its location is at roof part B, gives you the voltage and phase, horsepower, equipment branch, your disconnect at the unit, the wire size that goes to that exhaust fan, which is odd because on the label it's SF1, which would normally be reserved for supply fan, but it says exhaust fan. Maybe we should assume that that really is a supply fan. Now let's go back up to the top of the chart, and we'll see first one, EF1, equipment type. It's an exhaust fan. Its location is at the roof. Voltage and phase, the horsepower, the equipment branch, what type of connection to this exhaust fan. We have a direct connection, wire size, it's a motor, and a disconnect will be provided, it says in the unit. Let's drop down to RTU number 1, return fan on the roof, 480 for the power, 3-phase. The wire size shown here. Control panel with a VFD for variable frequency drive and lights furnished with unit. So this 3 number 12 and 1 number 12 ground is for the return fan at the roof. Here we have electrical power distribution. Let's take a look at the top of the page here, the equipment seismic restraint chart. Okay, we have all the lists on the left side of the different equipment, like an ATS, main distribution switchboard. We have transformers, panel boards. The equipment is located on the drawing. It shows the page number. When it comes to the anchorage or the seismic restraint of this particular type of equipment, we're going to be looking for a drawing. And for instance, let's just take this one. We have a T30 transformer. It's located on page E6.01. It's on detail or drawing number F-265-155-1, which would be found on page SR.E3. Now in this particular case, the E1 would be your seismic restraint page 1, SRE3 page 3, and there's also a page 2. So there's a seismic restraint. There's only 3 pages for electrical, 1, 2, and 3. Let's look toward the bottom of this chart, see if there's anything else. Okay, it's rather typical. Now let's go to page SR.E1 and take a look at what's shown there. Actually, the seismic restraint pages are going to be in another future video, so we'll skip that for a moment. We'll cover it later. Okay, let's take a look at the roof level, because we haven't looked at any of that on the electrical drawings yet. We'll start here on the left side of the page. Now you have, it's very hard to read here. Let me try zooming in a little more. Maybe it'll get better, but maybe not. Rooftop unit number 3, that would be like air handler number 3. Just different words being used here. We see a motor here on the left side and another motor on the right side. We have a junction box. We have a 2. Let's take and also a number 1. Let's take a look at our notes on this page. Okay, number 1, rooftop unit feeder shall be connected to the HVAC unit furnished VFDs, coordinate with Division 15. And the 2 was a junction box connection, is to be provided for the rooftop unit lights, light switches, and internal wiring furnished within the unit. Okay, let's jump back down there and take a look now. Okay, this particular motor here is hooked up on panel HEQ 2A1 circuit 5. That would be the EQ is the equipment branch, and this other motor at the other end is hooked up to, hard to read here, same thing, HEQ 2A1 circuit 6. So you can see all your power needs, what panel and circuit it's going to. Let's zoom out a little bit here and take a look what else is up here on the rooftop. Here at this end we can see, we'll zoom in here, we have a series of exhaust fans. Exhaust fan 7 is on LEQ 1B1 circuit 20. Exhaust fan 6 is on a motor control center EQ-11. Makeup air unit is on the equipment branch, the circuit 28. You can see here we've got a power receptacle. It's a waterproof receptacle because it's up on the rooftop that you need for servicing. You have to have a receptacle within 25 feet of all the equipment. So you can see this one here. There's the panel and circuit number. It's adjacent to here. Here we have another waterproof receptacle adjacent to this grouping. We'll move over a bit. Let's see this EF14. There should be a receptacle nearby. Here's one down here, just below it. There's your panel and circuit ID, and a note number 5, probably a non-fused disconnect. Let's take a look at that. 5, furnish and install a non-fused disconnect to serve EF14. There you have it. And you have some other items on the roof. You can see where you can easily read the panel and circuit to be used. See some junction box symbols here. MCC is your motor control center. Okay, we have 2 pages of details, E8.01 and E8.02. We'll take a closer look at this page. We'll see we have a bunch of miscellaneous rooms that give a room number that clearly shows the layout for within this data room 1B38. And we have cable TV, PBX, voice termination field, some conduits coming up. We have a security panel. We have data cable and data equipment on racks in the middle of the room, and this denotes a cable tray type of system for all the cables. We have 3 4-inch conduits to this room routed through the ceiling. We have 3/4-inch plywood backboard in this room to attach all these pieces of these NEMA cans to the wall. The next room shows another room, 1B38. Actually, it's showing you one view of that particular one of the elevation shots. There's elevations 1, 2, 3, and 4 of that same room. Show you exactly what it's going to look like. We have a voice and data faceplate layout shown here. We have another equipment layout room, 2A113, or A13, excuse me. And then there's elevation showing the room, elevation 1, 2, 3, and 4. So it gives you all sides of that room. And also the center of the room, we have a couple of racks that are floor anchored in the middle of the room. We got a voice data cable riser shown here, and a cable TV faceplate layout. Suspended cable tray, rated wall penetration detail. Here's your rated wall. So you stop your cable tray short, you come up with your cables and back onto the cable tray. Here's the T intersection shown here. Typical systems conduit termination at cable tray detail. So in the corridor we've got a cable tray. In some of the rooms or other spaces we have a conduit that stubs into the above ceiling space in the corridor or hallway where the cable tray is located, and then these cables just drop right into this cable tray and just run the length of the cable to wherever it's going. These are just stub outs through probably the corridor wall. They get fire stopped. They come in just above the cable tray, approximately 12 inches up from the cable tray, and just drop into this tray. All right, let's jump to the next page. Okay, on this page, top left, you have the round pole base detail for the lighting fixtures that are in the parking lot. Let's take a closer look. Okay, we have a note. We're going to bond the conduit to the pole with a number 10 green ground wire. We have a concrete base that's going to drop into the ground. There's some dimensions shown here and in the pole base schedule. Talk about the height of the pole. The minimum pier size would be our diameter, our depth below grade that needs to go, vertical rebar and circular ties there in that concrete. And it gives us some details about how to set the light pole on top of the pedestal, 24 inches minimum, of, as you can see here, above the typical ground elevation. Let's jump over, we'll see a sign, lighting and fixture mounting detail, patient care area branch panel ground bonding, typical, what's your typical electrical panel, how it should be labeled. This is a very old label. Today's labels probably have about 9 different things that need to be mentioned on an electrical panel per code. We have a ground electrode system showing how to connect a switchboard to an UFR ground, to the water piping, or to the building steel, and what size grounding electrodes you need to use. And here's some duct banks. These are buried items encased in concrete. This particular one is showing primary electrical service into the building, depth of burial, the thickness of the concrete around it, the spacing between the conduits. Next one is a primary telephone service duct bank, once again also encased in concrete with a different burial depth. And then we have the main switchboard feeder electrical service duct bank, which has quite a few conduits, and that's even deeper than the other duct banks. And it shows the spacing between and on center, depth of burial, the size of the conduits that'll be in that duct bank. Well, that concludes the review of the Surgical Specialty Hospital electrical drawings. Now I'm going to take you and show you another set of drawings that are a much more modern set, and you can see the difference in some of the symbols and the way things are shown, and also how clearly things will typically be shown on today's drawings. Here is a set of drawings. We're just going to look at the electrical section right now. This is a set of drawings that meets the 2016. It looks like, let me zoom in a little bit. Yes, 2016 California Building Code requirements. Let's take a look at the abbreviations that we have on these drawings. Notice how clear things will be once I remove the cursor. So here's the typical abbreviations that you would find on an electrical set of drawings. You might want to get familiar with just a few of these. After a while, it becomes very easy to understand, such as panel, PNL, PTS is a pneumatic tube station, PP, a power panel, PWR, power, REF, refrigerator, to name a few. So I'll show you a little bit more of the abbreviations here. There you go. And you can pause these recordings at any time if you want to spend more time with it. Now let's jump up. Okay, so now we got our standard electrical symbols. See how easy and clear this is to read? Let's start at the top. A1-3-5 is a three single-phase circuits to panel A with a common neutral. And A1 and 3 and 5 is a 1-3-phase circuit to panel A, no neutral. And an A, 1 and 3 is a 1 single-phase circuit to panel A with no neutral. And A, 1, 3, 5 is 3 single-phase circuits with separate neutrals to panel A. A straight line with an arrow at the end designates a home run to the panel or cabinet as designated. A straight line is a conduit run concealed in a wall or above finished ceiling unless otherwise noted. It'll be a 3/4 inch conduit with 2 number 12 wires in it. Conduit in or under a floor or underground, 3/4 inch minimum, with conductors, existing equipment or wiring as indicated, 2 number 12s. Sorry, it's a little difficult to read some of this. I haven't read this section before. Existing conduit run or equipment. Conduit run exposed, a conduit turned up, conduit turned down, conduit with seal-off fitting, 3/4 inch conduit stubbed out, 6 inches above an accessible ceiling. This is where it gets a little more interesting. You'll use this quite a bit more. 3 hash lines denotes a 3/4 inch conduit with 3 number 12 wires. 4 lines, 3/4 conduit with 4 number 12s. And you can just read your way through these as the conduits get larger and the wire sizes get larger. You'll see a symbol for flush-mounted lighting or power panel board, or a surface-mounted lighting or power panel board. Some terminal cabinets, surface-mounted distribution panel boards, lighting control panel. Now let's take a look at our electrical on the walls or in the ceiling or in the floor. On the left side, you can see a junction box with a J will typically be at 18 inches, or as noted. If it's above the ceiling, the symbol will look like this, and if it's in the floor, it'll be a hexagon. Let's drop down to a duplex convenience outlet at 18 inches, or as noted. Duplex convenience outlet at 42 inches. A quadplex outlet at 18, or at other heights. You can just keep looking down here. You might want to take a moment to look at these symbols. These are pretty typical. And you've got your duplex convenience outlet with GFCI at 2 different elevations, 2 different symbols here. You have your light fixtures, surface mounted or recessed, different symbols. The lights here that are shaded in, shading indicates it's a night light or it's on E-power. Have an exit sign symbol. Some switching symbols. Some descriptions for the plans. On this set of drawings, you can see we have some general demo notes and electrical general notes. Let's drop down. We have a lighting fixture schedule. This is a small project, very small. So we have an FX-1 2x4 recessed LED lighting fixture. Shows the lamps, the color and the brightness, the manufacturer. We have lighting fixture schedule notes. And electrical equipment seismic certificate schedule. This is for the new transformer and panel board and switchboard that needs to be installed. And it's showing the approximate dimensions, the approximate weight of the equipment, the catalog number and manufacturer. Is it floor or wall mounted? The OSHPD certificate number, how many of them that you've got on this project, and the reference detail number. Okay, here's a single line diagram. I'll try to walk you through this, okay? I'll start down in the bottom where the utility power comes into the building. Let's zoom in. Okay, we've got the power comes into the building to unit substation A. This is normal power, and what we're showing here is of course this is all existing. There's only a tiny bit of this single line diagram is going to show our new work. But let me see if I can walk you through this. The distribution switchboard, okay, this is 480, 277 volt, 3-phase, 4-wire, normal branch power. Okay, now we have a 600 amp or 1600 amp bus here, and coming off it we're going to have two 600 amp breakers, right? Coming off this switchboard, going up, we're going to go to another switchboard with a 600 amp bus, normal power. Up here we're going to have a 100 amp and a 350 amp breaker. Let's follow this up. This happens to be one of our new panels. That's why it's kind of more bold than the rest of the drawing. It's showing a P3N F5B panel. This NKH1 is going to show me the size of that conduit that goes from this normal branch switchboard to this panel, and it's also going to tell us what the wire size is. Perhaps we'll get to that a bit here in the future. Okay, we're also coming up, we have another conduit size and wire size that goes over and feeds to a transformer. Transformer T, BWNK, 225 kVA, 480, 208. Okay, and it's going to step that power down from the 480, 208 to the 120 volt, 3-phase, 4-wire. Coming out down at the bottom, you'll see we have a 1-inch conduit with a number 2-aught ground to ground that transformer, possibly to the building steel. Okay, we're coming down, and now we're at a new switchboard, BW-NKL, which is at the lower power, the 208, 120 volt, 3-phase, 4-wire, normal branch. And we've got several circuit breakers here. These are all, first three are spares for future work, but we're going to put this particular panel in now, panel P-1N 5 or F5B. The NKL3 tells us our conduit size and our feeder size going from this bucket or breaker up to our panel board. So that's the normal power system of our single line diagram. Now let's jump over to, from this single line diagram, we have normal power going in and being distributed to a couple of different levels here. But we've got one leg at 600 amp coming off of that and going over to an automatic transfer switch with a manual bypass and isolation switch. Now this normal power is going to hook up to an automatic transfer switch, or ATS BW2, 600 amp, and it's going to be a critical branch ATS. As you recall, we have 3 different branches of e-power: life safety, critical, and equipment, typically in a newer, more modern building. So there's my leg going up to the transfer switch that will typically be providing normal power. When we lose normal power, this leg here will trip over, and that will send annunciation over to, or controls over to, my emergency generators. Let me see if I can pull those up. They're not actually shown on this sheet, but from the emergency generator, we're providing power off of emergency distribution switchboard EMB. Comes up with looks like two 4-inch conduits with 4 number 500 KCM size cables plus one number 1 ground will connect to this ATS. So we have normal power here and we have E-power. We're typically running on the normal power, but in the event of a loss of normal power, this leg trips over, completes the circuit, and then we start drawing power off our generators. Okay, now let's continue up here. You can see here we have some, what's most likely some power from the ATS critical branch here coming up over to the equipment branch. So you can see we've got power coming from down here on the bottom. This is going to critical branch, and this 600 amp is going up to the equipment branch. From the equipment branch, we're going to be feeding emergency distribution switchboard BWEQ for equipment branch KH. That's going to be 480-277, 3-phase 4-wire equipment branch. So when the generators are on, this is all hot. Once the normal power drops out, we have a 600 amp bus. We got 2 spares, a 225 amp bucket or breaker here that's going to provide a power to panel ED-EQ. Once again, we know EQ is equipment branch. The EQ-KH1 is going to tell us my conduit size from this switchboard up to this panel board and tell us what wires are within it. Now also this equipment branch, you can see a 350 amp breaker. It comes up, goes to a transformer, which steps the power down from our 480 277 down to our 208 120 volt power. There's another ground that we need to have come off that transformer. This designates again wire size and conduit size. Comes down to this 800 amp bus. Then we've got a 225 amp bucket or breaker, and then we have another 225 that's going to go to an existing equipment branch power panel, which is P1E F5BA, and also to a P1E D81, and then a couple more spare buckets. Okay, so that covered us for the equipment branch. And as you recall, on this other ATS where we started out with a critical branch, it comes up and over, goes to this new emergency, see the N, new emergency distribution switchboard BWCKH, 600 amp bus, 2 spares in it. We got our breaker here that goes up. There's the size of the conduit in that particular table. It feeds L-3C F5B. And it gives you a little bit of a load verification information here. Let's see if there's anything else we need to talk about on this particular single line diagram. Now, some single line diagrams, as you'll find, are going to be, maybe anywhere from 1 page to 10 pages, depending on the complexity of the building. This is just a remodel, so we didn't need to show very much of the existing single line diagram. Okay, I think we've pretty much covered this typical routing. So we have the normal power coming in to the switchgear, and then we've got the generators providing power on the emergency side on the left side of the page. And both of these come together at a transfer switch, which means basically that everything's running on normal power except when we lose utility power, and then the power from the transformer, within 10 seconds the generator's got to kick in and provide full power, which makes these automatic transfer switches click over and run on e-power and provide your life safety equipment or critical branch power to the necessary equipment. Okay, that's enough for this page. On this page, you can see we have some panel boards. Let me zoom in. There's panel P1E, F5BA, and we had taught you earlier how to read the header here. It gives you all kinds of information you'll need to know. 208, 120 volt, 3-phase, 4-wire. The main is a 200 amp and the bus is rated at 225 amp. Okay, this shows the different pieces of equipment that will be connected or are currently connected to this particular panel. You'll see we've got an AC unit, receptacle, and Mercy Cool equipment and smoke fire dampers connected to this, and you notice all the spares. There's another power panel showing what's connected. Normal branch, surface mounted panel, 208, 120. Just a couple of circuits in use here. A critical branch power panel, very little load on it, and a normal branch power panel. Okay, let's jump up. Here is an existing equipment branch power panel. You see the EQ for equipment branch, and it's 480, 277. And here's a very important item that sometimes people can't find this on the plans. Let's talk about this. This is the feeder schedule. This is going to tell us the size of the conduit and the wiring inside that conduit that go from, for instance, from switchgear to panel board, etc. So remember we were talking earlier, we showed that symbol in the hexagon. Let's take a look here. Let's jump down to BWEQL, transformer, number of sets 2, conduits an inch, 2 4-inch. The wire's going to be 4 number 600 kcmil and a 1 number 1-aught ground in each of those 2 conduits. It's a copper wiring. It's going to give us the amperage and some additional information. What's most important on the feeder schedule to us is it shows the conduit size and the wire size between different pieces of larger equipment. Here's some miscellaneous details. At the top row, you're seeing a bunch of Hilti details that show how to deal with conduits going through walls or through the floors and how to fire stop them properly. And on the lower section, we have a couple of details on the bottom left here that show us how to support some light fixtures. And on the lower right, we have 2 details that show us how to support our conduits. Being this is a small job, most of our conduits are going to be 2-inch and less. So we've got 2 light duty types of details here. And you can see at the top of that, you know, these may be, let's take a quick look. 1/2-inch Hilti KBTZ with 2-inch embedment. And on these, this other detail is for supportive conduits 2 inch or less also. Oh, excuse me, the other was exceeding 2 inch, and this one is for 2 inch or less. Apologize. And you can see here we have a 3/8 diameter Hilti KBTZ with 2 inch embedment. But one thing that's very important to note here, that you need to be very careful with drawings, so that we don't have to brace or restrain some piping. You can see here that we've got a 12-inch maximum length of this support. So we've got to keep these conduits up real high to the ceiling system. If we go over 12 inches, then we might get into a situation where we've got to put some restraint on these supports for the 2 inch or less conduits. And there's a certain loads, if you look at the notes 1 through 5. Now let's jump over to the typical detail for conduits exceeding 2 inches. And you note that this also have a 12-inch maximum. So in a structural steel building where you've got to run your conduits, sometimes you're going to run into some beams that are 2 feet or 3 feet deep on the girders. So both these details can apply to you, but what you're going to have to do is every time you come to a girder or a beam that's greater than 12 inches deep, you're going to need to put some 90s in to get it underneath that beam to the other side and back up to the deck again. So the architect is intentionally given these details to suggest that, you know, there's not some issues relating to some seismic bracing that might be required. Because if it's 12 inches or less, we don't have to seismically brace. And there are certain exceptions to that that would be in your seismic bracing manual. Okay, shown here is just the location of this small remodel project. It's just affects 3 rooms. We put in a new rated wall, so we have to demo out some existing walls and doors, etc. shown here. Let's zoom in a little bit. So here's the total scope of our project. Hatched area all gets demoed out, these existing walls. Now here's a ceiling plan legend showing all the devices in the ceiling that will be removed. Here's a floor plan down in the basement. Let's zoom in on one of our electrical rooms. This particular electrical room is 1 hour rated. You can see our transfer switches down here on the bottom. Critical branch and an equipment branch transfer switch are providing power up to our electrical panels. You see the ones with the N are normal power, and the C would be critical, and the E would be equipment panels. And over here you can see CKH. C would be critical power, EQ equipment again on this transformer, and equipment power on the branch system for the switchboard. Here's the electrical engineer's ceiling plan legend for the lighting fixtures and the HVAC system. Okay, shown here is my little remodel project, reflected new ceiling plan. You notice that we have a total of 6 lights in this space. We have 4 lights on normal power. And you can see here it's on panel 3N, F5B, circuit 7. And we have 2 lights that are denoted filled in, which suggests that it's on E power. And that would be, the home run shows us that we're going to panel L3C, which would be C being critical branch of the emergency system, F5B circuit 3. And all 6 of these lights are the same. They're per that electrical fixture schedule. These are in FX-1. So you could go back to that schedule I showed you earlier, and that would tell you who made it, what size they are, all the different information you need to know about those lights. Okay, on this page, it's our specifications. Being it's such a small job, they just put the spec items for the electrical right in the electrical section rather than in a separate spec book. Let's zoom in and take a look at some of these. So panel boards give us some idea as to manufacturers of the panel boards, how they get made up, what type of cans to be used. You know, are they rated for exterior or interior exposure, NEMA 1 or NEMA 3R? Basically, how to go about instructions for ordering the different panels that the electrical engineer chooses to use. We have some fire alarm information here. Let's move over to nameplates and warning signs that we need to put. So nameplates designations shall clearly state. So this is what's going to be on a typical micarta type label mounted on the panel board or switchgear, etc. There's quite a bit of information that they're asking for on these nameplates nowadays. Even mentions how to attach the nameplate. Shall be mounted by self-tapping or threaded screws and bolts, or by rivets, but no adhesive. Switches, disconnect, and safety equipment. A little information on what the electrical engineer is requesting. Also, dry transformers. Let's jump over to conduits and raceways. What types of conduits can be used on this job? Certain sizes might have to be rigid steel or IMC steel. How much flex you can use on the job? Is it steel flex or is it aluminum flex? What's the maximum length? Also on the conductors, what they're specifying should be used. Is it stranded or solid wiring? Outlets and junction boxes, you know, what type of boxes are to be used. There's different grades, different costs for different products. How to go about achieving some grounding requirements. Electrical general requirements. Materials, guarantees, work responsibilities, workmanship issues, working within certain areas of the hospital, what you can and can't do while you're running your work, what tests and maybe inspections need to be completed. And a little bit more information on switchboards and other items. We don't need to get into the specifications. So that's going to be the end of this electrical blueprint reading plan review.